All right, guys, let's begin with, again, just another reminder, weather maps and scripts are going to be due. They've been due, so turn those in as soon as possible if you've not completed them already. You'll notice if you've not completed those will be zeros in the grade report. We've also got projects due next month and tests next week in the form of 3 separate quizzes. Number 1, what is the charge setup of lightning? I need a diagram for that, 2, how does lightning strike and what is thunder? And 3, what safety precautions should be taken? I'm going to help you guys answer number 3. So focus on 1 and 2. Give you guys 10 seconds to add to the chat. Otherwise, I'll walk you through it like usual. 10 seconds, add to that to the chat. What do you think about maybe 1 or 2? 1 or 2 for extra added participation grade. See what you guys remember. Okay. Let's go and continue then. Number 1. Okay. You have 2 parts to a lightning bolt. Okay. A lightning bolt is not going to be 1 bolt. It's going to be 2. Okay. And lightning does not strike you at your head first. It actually surges through your feet first. So you have 2 bolts, as you can see here. Okay. 1 bolt comes from the cloud. The other bolt comes from the ground. The top bolt is negative, and we call that the step leader. The bottom bolt is positive, and we call that the return stroke. Okay. So lightning is in 2 bolts, 2 bolts. So with that being said, is it going to strike the ground or strike the air? Well, it's going to be striking the middle of the atmosphere. Okay. And also, what is thunder? Okay. It's going to strike the middle of the atmosphere. Okay. And when it strikes, because again, 1 bolt comes out of the ground, 1 bolt comes from the bottom of the cloud, opposite charges attract. Okay. And if you guys remember, the speed of light is faster than the speed of sound. So with that being the case, right, you're going to see the flash of light happen so fast, it looks like 1 bolt. But in slow motion, it's 2 bolts connecting at extreme speeds. The thunder is the sound of the explosion that is made from those 2 lightning bolts connecting in the middle of the atmosphere. Okay, it's an explosion that superheats the air up hotter than the surface of the sun. Okay, so that is going to be again, thunder explosion in the middle of the atmosphere. Number 3, this is super important, safety for lightning, because we live in one of the lightning capitals of the U.S., right? Florida gets the most lightning out of any other state in the United States. Okay. Lightning can impact a lot of us because of where we live. So let's go ahead and check out for number 3. What is the safety in regards to surviving a lightning strike? Let's go ahead and check that out. So how do we survive a lightning strike? How do we position our body? How do we go about that? Let's check it out.
Field during a lightning storm, which...
If you guys have issues hearing, let me know. I think you should be able to hear it though.
Caught in the middle of a big open field during a lightning storm, which of the following uniforms would be most likely to keep you safe? A thick wetsuit, a Superman costume, a medieval coat of armor, or your birthday suit? If you answered medieval coat of armor, you might be a little crazy, but you'd also be right. You'd be crazy, of course, because lightning is much more likely to strike metal than rubber, fabric, or bare skin. The reason is that lightning bolts are just long streams of fast-flowing electrons looking for the easiest path from point A to point B, and no everyday material provides an easier path than metal.
1 second, I need to make sure the students can actually, okay, they can see, yeah, my bad.
So why would a material that lures lightning bolts keep you safe during a thunderstorm? Ironically, for the exact same reason it attracts the lightning in the first place. Metal is a great conductor of electricity. Electrons glide so easily over metals that they barely penetrate into the surface. And if an electrical current happens to be moving over a hollow metal container, like a can or a box or even a welded coat of armor, the current won't reach the inside of the container. Physicists call this kind of container a Faraday cage, or in the case of the steel-woven clothing worn by linemen working on high-voltage wires, a Faraday suit. In fact, your car is an everyday example of a Faraday cage, which is why, despite what you may have heard about rubber tires, it's actually the closed metal chassis surrounding you that keeps you safe. It channels lightning around rather than through you. Of course, if you're away from your car...
This is the idea, guys. In your car, you are completely safe from lightning. Okay, in a plane, you are completely safe from lightning. In a convertible, not the case though, because it's like a leather ceiling that can open, right? But again, the metal case is what keeps you from getting electrocuted, and the lightning will just travel on the outside of that. It won't go through the metal and into the car. It only travels on the outside. So I showed a video, guys. There are cars get struck by lightning a lot sometimes, and it doesn't stop the car or anything, right? So cars, if you're outside during a thunderstorm, stay in a car, okay? In a plane, lightning, you're gonna be fine. The clouds affect the plane more, the lightning doesn't affect the plane, okay? Let's continue and figure out how do we position ourselves to best protect us from injuries or, again, life-threatening situation from lightning.
Channels lightning around rather than through you. Of course, if you're away from your car and get caught in an open field during a storm, chances are slim that you'll have a medieval coat of armor or high voltage line suit handy. In that case, whether you're naked or in costume, your body unfortunately happens to be a better electrical conductor than both air and soil, so it provides a great shortcut for traveling current. Stand upright and you're the fastest route for a descending lightning bolt. Lie down and you're the best path for current racing along the ground from a nearby strike. So the best thing to do is crouch low and keep your feet close together.
There you go.
Crouching low is obvious, but similarly important, when your feet are right next to each other, your legs don't make for much of a shortcut for the current to get from A to B. And even if they are the best path for the lightning, when your feet are the only thing touching the ground, then the current will most likely travel up one leg and down the other, missing critical organs like your heart, something these cows couldn't avoid. But actually, the real best thing to do is avoid lightning altogether, and head indoors when you spot a storm on the horizon.
Okay, so really important stuff. Make sure we're listening, guys, because this is stuff that could save our lives or our friends' lives, okay? What do we need? We'll do that later. One sec. We'll do that question later. Let me go ahead and find, let's see. Fix this real quick, guys. 1 second. Okay, fixed it. Okay, so here's what you need to do. This will be the answer for number 3, okay? As you see in the picture on the right, you need to crouch down. You need to make yourself as low as possible. Don't stand up straight. Don't lay down. That makes you more vulnerable. Okay, you need to crouch down. Kind of crouch like up in a ball, right? When you do that, you got to put your heels together. Okay, put your heels together because the lightning will surge through less of your body. Okay, so if you stand normal, the lightning will go through your legs and into your torso, and that could be devastating or do severe damage to your organs. Okay, your heart, your nervous system. So crouch down, make yourself less attractive to the bolt. Put your heels together. That way, the only part of your body that may get shocked is your feet. Okay, that'd be much better than if it was for your legs and your arms and your torso. Okay, cover your ears too because thunder will be super loud and it could pop your eardrums. Things we could see with this are again partial hearing loss, partial vision loss, burns to the skin, and in 10% of cases, fatality as well. Okay. Also add the idea of a Faraday cage. It's just the idea that anything that's a metal case that's closed off to the outside is safe from lightning. So cars are safe, planes are safe from a lightning strike, and we call that a Faraday cage. Okay, take a picture of that if you need that. We're going to move on here. Okay, and then there's the position again we can see there. All right. Go at table of contents. We're going to start very briefly today, tornadoes. Table of contents, add pages 20 to 21, tornadoes. Okay, any questions, comments? All right, moving on. Let's do our first question of the day. Again, you need to answer in the chat. Please answer in the chat. Number 1, which is not an ingredient for creating thunderstorms? So which of these 4 does not help create thunderstorms? Is it A, moisture, B, electric currents, C, lifting air, or D, unstable atmosphere? Give me your answers in the chat. Again, which of these does not create thunderstorms? Again, I'm going to need answers from Lakia, Yorkies, Tatiana, Sanaya, Michaela, Joseph, Irina, Giovanni, Evelyn, Diego, Daniela, Damiona, Amira, I need answers, need answers. Thank you, Tatiana and Irina, for your answers. Lakia, thank you. Just to make sure you guys are awake, you guys are listening, and things you're going to see actually on your test coming up next week. Thank you, guys. Like what I see, give you guys 10 seconds, 10 seconds. Thank you, Daniela. Thank you, Diego. Give it your best answer, guys. Going to see it next week on the test. Damiana, thank you. Okay, let's take a look here, guys. I'm going to give shout outs to Damiona, Evelyn, Diego, Yorkie, Sanaya, Giovanni, Joseph, Lakia, and Tatiana. Great job, everybody. You got the correct answer, which is B, electric currents. That is the correct answer. Again, electric currents come from storms, but they don't directly create the storm. That includes moisture, lifting air, unstable atmosphere is what's going to help the cloud grow. The electricity does not help the cloud grow. Okay, moving on. We'll skip that question. I got to save us opportunities. Let me go ahead and move this question to another area here. 1 second. I'm going to move on, add some more stuff for lightning. We might start some tornado stuff. Hold on. Okay. What did I have? Any more lightning stuff? Let's see. Okay. Let's move on then. Going to start with tornadoes. Here I'm going to show you a cool video of a tornado close up in case you didn't know or haven't seen one as good or as close up as this. Again, tornadoes are not as common in Florida. So that has to do, we can maybe explain that in a little bit. But let's go check out this real footage of a tornado close up. This video, these are of storm chasers. Yes, there are people who are paid weather scientists who get to chase and drive up close to these tornadoes. But again, it is life-threatening, and some storm chasers do not survive. So dangerous job, but pretty cool job nonetheless. Let's go ahead and check it out. I'm just going to play a minute of this video, guys, so bear with me here. Careful with your volume, guys. Careful with the volume. I'm going to turn it down just a little bit if it's too loud. And as you can see, here is a semi-truck that's just been tossed aside like it's a piece of paper. That's how strong tornadoes can get. So very, very dangerous. We got a massive whirling structure of wind that's going to basically act like a vacuum and destroy everything in its path, right? So just some discussion questions. No need to write these down. What exactly causes these tornadoes, these storms? Why are they more common in the mid? Again, it has to do with air, and we're going to explain that here in a minute. Why are tornadoes more common in the Midwest than here in Florida? Okay. Well, it has to do with they're more common in the Midwest, guys, because the air is a little drier. They do get storms, but the air is drier. The air in Florida is much more humid and has much more moisture. So that air being really heavy, we do get tornadoes, but they don't get as bad as like in Oklahoma, Texas, Kansas, right? And then if there is a tornado, you need to find shelter, duck, and cover. So if you're in a car, you probably want to go to a ditch or under a bridge, away from the debris. Again, if you're in a car, the windows will shatter. The car may get tossed around. Being in a ditch is better. And then obviously being inside in the lowest room with no windows would be your best idea as well. Okay. So last thing of the day I want to get into would be these two questions. Again, you're going to write these down on page 20. What helps create the cyclone of a tornado? Number one. And then number two, how fast can tornado winds get and how long can one tornado last? And just so you guys have this as well, okay, I want you guys to write on page 20 that tornadoes, again, write this on actually page 21, tornadoes are formed from supercells and they are violent whirling columns of air in contact with the ground, again, destroying everything in its path. So we're going to write that down on page 1. I'll give you 10 seconds to take a picture, and we'll move on to our last thing of the day, which is the video. The video 2 questions, then we'll call it a day. Got a video 2 questions, then we'll call it a day. Again, page 21, page 21. I'm going to write it down on page 21. All right, let's go to our last video, guys, to our questions. It says right here again, how do they form? How fast can they get? And how long do they last? Let's check it out. Last activity of the day. Really good video, by the way. Really good video.
They call me the tornado chaser. When the wind is up and conditions are right, I get in my car and...
Is anybody have issues with the audio, by the way? I have my speakers connected. Usually I don't connect the speakers. So if you have any issues with the audio, if it sounds like less quality or if it's a lower volume, let me know. I'm just kind of trying something new here, see if it works okay. So again, let me know in the chat if the volume is not as good or if it's changed at all. If nobody says anything in the chat, I'll assume it's okay. Let's check it out. Again, forms a cyclone, and then how fast can tornadoes get and how long do they last? Let's check it out. Let's check it out.
Follow violent storms. Crazy you say? Perhaps, but really I chase these sky beasts to learn about them. I want to share with you what I know. Tornadoes are rapidly rotating columns of air that form inside storms, then connect with the ground via a funnel of cloud. When that happens, they tear across the earth, posing a huge threat to life and property. Because of this, there's a great deal of research into these phenomena. But the truth is, there's still a lot we don't know about how tornadoes form. The conditions that may give rise to one tornado won't necessarily cause another. But we have learned a lot since people first started recording tornadoes, like how to recognize the signs when one is brewing in the sky. Are you coming along for the ride? Tornadoes begin with a thunderstorm, but not just any thunderstorm. These are especially powerful, towering thunderstorms called supercells. Reaching up to over 50,000 feet, they bring high-force winds, giant hailstones, sometimes flooding, and great flashes of lightning too. These are the kinds of storms that breed tornadoes, but only if there are also very specific conditions in place. Clues that we can measure and look out for when we're trying to forecast a storm. Rising air is the first ingredient needed for a tornado to develop. Any storm is formed when condensation occurs. The byproducts are the clouds. Condensation releases heat, and heat becomes the energy that drives huge upward drafts of air. The more condensation and the bigger the storm clouds grow, the more powerful those updrafts become. In supercells, this rising air mass is particularly strong. As the air climbs, it can change direction and start to move more quickly. Finally, at the storm's base, if there is a lot of moisture, a huge cloud base develops, giving the tornado something to feed off later, if it gets that far. When all these things are in place, a vortex can develop enclosed by the storm and forming a wide, tall tube of spinning air that then gets pulled upwards. We call this a mesocyclone. Outside, cool, dry, sinking air starts to wrap around the back of this mesocyclone, forming what's known as a rear flank downdraft. This unusual scenario creates a stark temperature difference between the air inside the mesocyclone and the air outside, building up a level of instability that allows a tornado to thrive. Then the mesocyclone's lower part becomes tighter, increasing the speed of the wind. If, and that's a big if, this funnel of air moves down into that large, moist cloud base at the bottom of the parent storm, it sucks it in and turns it into a rotating wall of cloud, forming a link between the storm that created it and the Earth. The second that tube of spinning cloud touches the ground, it becomes a tornado. Most are small and short-lived, producing winds of 65 to 110 miles per hour. But others can last for over an hour, producing 200-mile-per-hour winds. They are beautiful but terrifying, especially if you or your town is in its path. In that case, no one, not even tornado chasers like me, enjoy watching things unfold. Just like everything, however, tornadoes do come to an end. When the temperature difference disappears and conditions grow more stable, or the moisture in the air dries up, the once fierce parent storm loses momentum and draws its tornado back inside. Even so, meteorologists and storm chasers like me will remain on the lookout, watching, always watching, to see if the storm releases its long rope again.
Okay, guys, really good animation going over tornadoes for us. Okay, so let's discuss the ingredients mentioned, okay? In the diagram that was shown, we had these three things, okay? We had a supercell. A supercell is a super strong thunderstorm, massive cloud. It's got a ton of moisture in it, okay? You gotta have a massive thunderstorm. Then you've gotta have really strong wind moving up and down. We call these updrafts and downdrafts. And then just like you spin, like one of those, like Beyblades or tops spinning, you got to have a sideways spin. We call that horizontal wind or horizontal shear. That's going to create tornado, right? So like I said, like a spinning top or a Beyblade, if you guys remember those from back in the day, okay? It's got to spin it, right? Gets the funnel cloud. Here's a supercell down here, by the way. That's a picture. Pretty cool. And how fast can they go? They can reach up to 200 miles per hour and last usually somewhere around an hour. They don't never usually lasting longer than that. So somewhere around an hour, and they can go above 200 miles per hour. Some going up to 300. But the worst of the worst will be a 200 plus. Okay. So again, have that picture ready. And with all that being said, guys, I think we're going to call it a day with this. Let me go ahead and just double check attendance. And just as a reminder, guys, complete those scripts and maps. I'm probably going to post a new assignment, I think, tomorrow. So have that ready. Again, maybe a new assignment tomorrow. I think it's just going to be like a writing assignment. Like just answer a few questions and then type out your answers. Probably what it's going to be. Okay, let's go ahead and check it out. Let's see. I got Amira, Damiona, Daniela, Diego, Evelyn, Giovanni, Irina, Joseph, Lakia, Michaela, Sanaya, Tatiana, Yorkies. Okay.